I am Fatima Saladaga, a student of Kapalan College of Agriculture Sciences and Technology, taking Bachelor of Science in Secondary Education, major in Mathematics. In this video, I will try to help you learn a linear programming problem, specifically in solving transportation problem, using the three methods. First method is the northwest corner method. Second method is the least corner method. And the third method is the Vogel's approximation method. Also, I will include the optimal testing using Modi method. To help you understand more, let's answer this problem together. We are going to start from the upper left corner to the lower right corner. Since this is the northwest corner, then we're going to start with this cell. We are going to find the demand and supply. And for this cell, we have 45 for the demand and supply is 35. The smallest between the two is 35. This exhausts the capacity of S1 and leaves 45 minus 35 equals 10 units with P1. Let's continue to the next cell. Here the demand is 10 and the supply is 50, and 10 is the least unit. The first column meets the complete demand of D1 and leaves 50 minus 10 equals 40 units with S2. For this cell, we have 20 for the demand and 40 for the supply. The least value is 20. This meets the complete demand of D2 and leaves 40 minus 20 equals 20 units with S2. Let's move on to the next cell. The demand here is 30 and the supply is 20. The least value is 20. This exhausts the capacity of S2 and leaves 30 minus 20 equals 10 with D3. Next, the demand for D3 is 10 and the supply for S3 is 40. The least unit is 10. Third column was satisfied and leaves 40 minus 10 equals 30 units with S3. The rim values for S3 equals 30 and D4 equals 30 are compared. The smaller of the two is 30. That is assigned to S3 and D4. Now we have the initial feasible solution, and let's solve for the minimum total transportation cost. 8 times 30 5 plus 9 times 10 plus 12 times 20 plus 13 times 20 plus 16 times 10 plus 5 times 30 equals 1,180. We are going to find out the smallest transportation cost or the least value among these cells. Since the smallest transportation cost is 5 in cell S3 and D4, we are going to start with this cell. The demand is 30 and the supply is 40. The allocation to this cell is 30. This satisfies the entire demand of D4 and leaves 40 minus 30 is equals to 10 units with S3. The next list value is in the cell S1 and D2, which the demand is 20 and the supply is 35. The allocation to this cell is 20. This satisfies the entire demand of D2 and leaves 35 minus 20 equals 15. Next, the smallest transportation cost is 8 in cell S1 and D1 with a demand 45 and supply 15. The allocation to this cell is 15. This exhausts the capacity of S1 and leaves 45 minus 15 equals 30 units. The next smallest transportation cost is 9 in cell S2 and D1. The demand is 30 and 50 is the supply. The allocation to this cell is 30. This satisfies the entire demand of D1 and leaves 50 minus 30 equals 20 units with S2. The smallest transportation cost is 13 in cell S2 and D3. The demand is 30 and the supply is 20. The allocation to this cell is 20. This exhausts the capacity of S2 and leaves 30 minus 20 equals 10 units with D3. The remaining smallest transportation cost is 16 in cell S3 and D3 with a demand of 10 and supply 10. So the allocation to this cell is 10. This is the initial feasible solution. Now let's solve the minimum total transportation cost. 8 times 15 plus 6 times 20 plus 9 times 30 plus 13 times 20 plus 16 times 10 plus 5 times 30 equals 1,080. We are going to find out the row penalty and the column penalty for every row and for every column. To get the row penalty and the column penalty, we need to find the least and the second least value of every row and every column. For the first row, we have 6 as the least value and 8 as the second least value. So 8 minus 6 is equals to 2. For the second row, 9 and 7, 9 minus 7 is equals to 2. 9 and 5 for the third row is equals to 4. And for the first column, 9 minus 8 equals to 1. Second column, 9 minus 6 is equals to 3. Third column, 13 minus 10 is equals to 3. And the fourth column is 7 minus 5 is equals to 2. To get the allocation, we need to find the maximum penalty from row or from column. And the maximum penalty is 4. That occurs in row S3. And allocate the allocation to the minimum Cij, which can be found to the S3 and D4, which is 5. It satisfies the demand of D4 and adjusts the supply of S3 from 40 to 10. In the second table, first row, 8 minus 6 is equals to 2. Second row, 12 minus 9 is equals to 3. Third row, 14 minus 9 is equals to 5. First column, 9 minus 8 is equals to 1. Second column, 9 minus 6 is equals to 3. Third column, 13 minus 10 is equals to 3. The maximum penalty is 5 that occurs in row S3. And we are going to allocate 10 to the minimum Cij in the row, which is 9. It satisfies on supply of S3 and adjusts the demand of D2 from 20 to 10. The penalties: first row 2, second row 3, first column 1, second column 6, third column 3. The maximum penalty is 6 that occurs on column D2. Now we were going to allocate 10 to the minimum Cij, which can be found on the cell S1 and D2. It satisfies the demand of D2 and adjusts the supply of S1 from 35 to 25. The penalties are row 1 is 2, row 2, 4, column 1, 1, column 3 is 3. Now we can see the maximum penalty is 4 that occurs on row S2. We will allocate 45 to the minimum Cij in this row, which is in the cell S2 and D1. It satisfies the demand of D1 and adjusts the supply of S2 from 50 to 5. We only have penalty from row 1, which is 10, second row 13, third column is 13 minus 10 is equals to 3. The maximum penalty is seen on the row S2, which is 13. We are going to allocate 5 to the minimum Cij, which can be found on the cell S2 and D3. It satisfies to the supply of S2 and adjusts the demand of D3 from 30 to 25. Now for the last row and column, we have 10 as the maximum penalty, which occurs on the row S1. The maximum allocation in this cell is 25 to be allocated to the minimum Cij in this row, which is S1 and D3. It satisfies supply S1 and demand of D3. This is the initial feasible solution. The minimum total transportation cost is 1,020. To have our Moody method, we are going to use this data from the Vogel's approximation method. As you can see in the table, we have 6 allocated cells that we will going to use to solve our Moody method. The step 1 is finding Ui and Vj for all occupied cells. Using this formula where Cij is equals to Ui plus Vj. To solve for every Ui and Vj, this is the guide we should follow what to subtract to get their value. Now let's solve.
Let U1 is equals to 0. So we have V2 is equals to 6 minus 0 equals to 6. U3 is equals to 9 minus 6 is equals to 3. V4 is equals to 5 minus 3 is equals to 2. V3 is equals to 10 minus 0 equals 10. U2 is equals to 13 minus 10 equals 3. And V1 is equals to 9 minus 3 equals 6.
Now we have value for every Ui and Vj. U1 is equals to 0, U2 is equals to 3, U3 is equals to 3, V1 is equals to 6, V2 is equals to 6, V3 is equals to 10, and V4 is equals to 2. Let's proceed to step 2. Let's find Dij for all unoccupied cells, where Dij is equals to Cij minus Ui plus Vj. This is a guide we can follow in solving every Dij.
V11 is equals to 8 minus 0 plus 6 is equals to 2. V14 is equals to 9 minus 0 plus 2 equals to 7. V22 or V22 is equals to 12 minus 3 plus 6 equals to 3. V24 is equals to 7 minus 3 plus 2 equals to 2. V31 is equals to 14 minus 3 plus 6 equals to 5. And V23 16 minus 3 plus 10 equals to.
Let us observe the table. All the data from Dij are positive. Since all Dij is greater than or equal to 0, the final optimal solution is arrived. The minimum total transportation cost is equals to 6 times 10 plus 10 times 25 plus 9 times 45 plus 13 times 5 plus 9 times 10 plus 5 times 30 is equal to 1020.
I hope you have fun and learned something from me. Thank you for watching this video. Toodles!